Hello, in this video we are going to go over the solution of the problem 498, diagonal traverse of a matrix, and we are going to use BFS. Imagine that we are given a matrix like this one, and our goal is to traverse this matrix in a diagonal orders. For example, if I reshape this matrix and show that in this format, you can see I have different diagonal levels. The first one is the element 1, the next one is 4, 2, the third one is 7, 5, 3, next one 8, 6, and the last one is 9. Also, we are going to traverse it in a zigzag pattern. So for example, for h equals 0, first layer, we are going to move from left to right. For the next layer, we move from right to left, and so on. As the result, we should get an output like this. Okay, let's start writing the code. Okay, the first thing that we are going to do is to import DQ. Say from collections import DQ. And then I want to initialize the queue. I define a variable queue as DQ, and then I initialize that with the coordinate location of the top left corner element, which is 0 and 0. Then I'm going to define a variable to record the visited nodes. I'm going to call it scene as an empty set at the beginning. Also, we add to the scene the coordinate location of the top left element. And at the end, we are going to return a list. Let's call it as zigzag result. We initialize that as an empty list. And at the end, I'm going to return this list. Okay. Now we start our while loop and say while queue. The next thing that we need to do is to pop left the nodes from the queue. We say for I in range of lengths of queue, because our queue could have different lengths at different heights. For example, at height 0, the length of queue is 1, but at height 2, it's 3. Okay, we are going to pop left, and it's going to give us the coordinate location R and C. Now I'm going to define a temporary variable and say temporary variable of queue level node, and we initialize that as an empty queue. Then I'm gonna say if height is even. In that case, I'm going to append to this temporary variable and say tmp dot append, and I'm going to append the value of the grid at the location R and C. Say grid R C. And if we are at an even height, for example h equals 1, we are going to move backward from right to left. So because of that, we say tmp queue level node dot append left grid R C. Then I'm going to go and visit neighboring nodes of R and C. We say for neighboring R, neighboring C in two directions, because in the grid, for example, if I'm at node 1, I need to visit 2 and 4. Okay, so I come here and say two directions. The first direction is the one row below that. We say R plus 1, same column. And the second direction is same row, one column forward. Also, we should make sure that if NR and NC are in the bounding of the grid, we say if NR is greater than or equals to 0 and less than capital R, and NC is less than capital C. And let me also define capital R and capital C at the beginning. Say capital R, capital C, length of grid, and length of the first row of the grid. So capital R is the number of rows, and capital C is the number of columns in our grid. Okay. Also, I'm going to add another condition and say if NR and C not in scene. We need this statement because when I'm at, for example, node 4, I'm going to add the neighboring 7 and 5. Then we go at node 2. I don't want to add 5 two times. So because of that, I'm going to have this statement here. Okay, if a statement is true, we are going to append that to our queue. We say queue dot append nrnc, and we add to our scene dot add nrnc. Also, we use this variable h. Let me define that. At the beginning, that is 0, and inside the while loop, that's gonna increment 1. Okay. Also, inside the while loop, we are going to extend to this zigzag result list and say extend, and we extend that temporary variable we created. But this temporary variable, if you look here, that is a queue, and if we want to extend that to a list, I just need to have a list before that to convert that to a list. Okay, now we have the solution, and let's run it. Okay, we get this answer. So this is what we expect to see, that has a diagonal traversal in a zigzag pattern. Now let's talk about time and space complexities. For the time complexity, we are conducting BFS, so we are going to visit each node only once. So the time complexity is order of n. For space complexity, we are creating also that queue in a worst case scenario that would have the size of n. And also this list that we are returning at the end, zigzag result, at max could have n elements. As a result, the space complexity is also order of n. Okay, this is the solution of the problem 498, and thank you so much again for watching this video.